right, so I'm back. We're gonna do method. We're gonna do the convolution using method two, which is just applying um, the properties of convolution and using things like the sifting method. So here we go. We have y of n equals x of n convoluted with h of n. Now h of n is defined as two scaled and shifted impulse functions, right? So if we wanted to, we could let h of n equal h1 of n plus h2 of n, where h1 of n equals 2 delta n plus 1, and h2 of n equals 2 delta n minus 1. Okay, so we get that out of the way. So let's rewrite our convolution. Y of n is equal to x of n convoluted with h of n. And using our definitions that we made right here, and x of n convoluted with h1 n plus h2 of n. Convolution is distributive, so y of n is equal to x of n convoluted with h1 of n, draw that one nice there, plus x2, or excuse me, not x2, just x of n convoluted with h2 of n. Now we can replace h1 and h2 with their scaled and shifted impulse representations. So we're going to get y of n is equal to x of n convoluted with, convolved with, where are we? Oh yeah, 2 delta n plus 1 plus x of n convolved with 2 delta n minus 1. Now remember the sifting property that x n convolved with delta n minus n0 is going to equal x n minus n0. So that's the sifting property. So we can apply that to right here. So then we're going to get y of n, 2 is a scalar, and this is a linear operation, so we can just pull the 2 all the way up front. So we get 2 x n, and our n sub 0 is negative 1 in this case. We have the negative sign here, so we can negate that. But we're going to have just change it out with this. So we have x evaluated at n plus 1, and then we do plus, and we have to do the same thing over here. We can pull this 2 out front because it's a linear operation, and then we're going to evaluate at n minus 1. So it's 2x n minus 1. Now let's bring this up here. And x of n is nothing but a bunch of delta functions itself. So we can replace that. We can replace x of n and our y of n. So y of n is equal to 2x n plus 1 plus 2 x n minus 1. So now we'll change mouse. Now what we'll do is we'll take this definition of x of n and we're just going to plug it in to each one of these. Let's get off there. So y of n is equal to 2. Now let's change out. So we take x of n plus 1. So we take this term here and we make it an n plus 1. We take this n, make it an n plus 1. We take this n and make it an n plus 1. So we'll have delta n plus 1 plus 2 delta n plus 1 minus 1 minus delta n plus 1 minus 3. I'm going to run out of room here, but and that's so that was the first term here, right? Now we have to do the second term, which is essentially, it's almost the exact same thing, except we're going to have an n minus 1 here. We're going to have an n minus 1 instead of n plus 1. So let's do that. 2 delta n minus 1 plus 2 delta n, that's an n plus, excuse me, let me start this term over. I'm screwing it up. We did delta n evaluated at n minus 1. Now we did 2 delta n minus 1 evaluated at n minus 1. So we have n minus 1 minus 1 minus delta evaluated at n minus 1 minus 3. And now we just clean it up. 2. Let's factor this 2 all the way up front. So we're just going to go like this. So we have delta n plus 1 plus 2 delta plus 1 minus 1 n plus 1 and minus 1 right here. Those equal 0 minus delta n plus 1 minus 3. So that's delta n minus 2 plus, we already factored that 2 out. So that's delta n minus 1 plus 2 delta n minus 1 is n minus 2. And then that last term, negative 1 minus 3 is delta n minus 4. And we have a like term right here we can collect, and a like term right here we can collect, and we can redistribute the 2 back out. And we will end up with n plus 1 plus 2 delta n. Let's bring this one first so we're in that correct order, that shifting order. And then plus 2 delta n minus 1 minus, well actually we have, so right here we have 1 delta being evaluated at n minus 2, and we have 1 negative, and then 2 positive 1, so that gives us 1 positive 1, and we have to multiply it by 2, so that'll be a positive right here. 2 delta n minus 2, and then minus 2 delta n minus 4. Oh, I forgot to, I forgot to multiply this 2 by that 2. So that's going to be 4 delta n right there. And that's it. If you watched the previous video, you saw when we did the table. So at -2, well, there's nothing here. If we change on any of these with any ends with a -2, well, we're gonna have 1, -2. We'd have -1, -2, -3, -4, -6. We'd have no delta function being evaluated at 0. So all those terms would be 0. Well, I have -1. Well, if we put a -1 in here, we get -1 plus 1. So we have a delta being evaluated at 0. So that's going to give us a 1. And then it's going to get multiplied by the 2. And that's going to get multiplied by 2. Let me write that out real quick. I'm sorry. 2 delta -1 plus 1 is equal to 2 delta 0, which equals 2 times 1, which equals 2. So this is going to be 2. And then y of 0 is going to be 4 times, that'd be this one right here, 4 times 1, so we get 4. And like in the previous video, we end up with all the same points. It's just finding those same things in a different method. And I will be back probably not till a couple hours from now to do the graphical methods. Thank you.